Good morning to everyone. MT8791 Embedded System Design for final year 7th semester Mechatronics Regulation 2017. So in this video we are going to study about the Unit 1 Introduction to Embedded System Design. So in this lecture we are going to concentrate what is meant by embedded system and what are the classifications of embedded system and what are the examples and one detailed examples about an embedded system, right? So also in this lecture we are going to concentrate what are the opportunities and how far we have to develop to be an engineer, embedded system engineer. So in this lecture we are going to concentrate what are the various opportunities and what are the various technologies we have to update to be an embedded system engineer. So in the first slide, we are going to see about the embedded system design syllabus. So in this Mechatronics MT8791 for final year embedded system design syllabus, in Unit 1 we are going to see about the embedded system, what is meant by embedded system, design process, challenges and common design metrics, and hardware software co-design process. In Unit 2, we are going to see about the real-time operating system. What is the difference between operating system and real-time operating system? What are the scheduling? And what is meant by message queues, mailbox, pipes, encapsulating semaphores, queues? What is meant by the VX, QNX, and VXWorks, Windows CE? So like this, we are going to study about this real-time operating system. The next Unit 3, we are going to see about the PIC microcontrollers. So in this PIC microcontrollers, we are going to study about the instruction set, addressing mode and timers and the other peripherals like analog to digital converters. So in Unit 4, we are going to see about the embedded networking. So embedded networking, we are going to see about the control area network bus and the inter-integrated circuit bus and the global system for mobile communication, GPRS, ZigBee. Likewise, we are going to see about in Unit 4. So in Unit 5, we are going to see about the embedded programming laboratory. So in this 5th unit, we are going to study about various programming for embedded system laboratory. So in this IO programming and interrupts and timer applications. So in this 5th unit itself, we are going to concentrate the programming. So for this syllabus, for this subject, we are having the Frank Wahid and Tony John Giveris embedded system design, a unified hardware and software introduction. The next Raj Kamal, embedded system architecture programming design. The next John B. Beatman for 3rd unit, design with the PIC microcontrollers. Right. So these are the textbooks we are having. The next one is what are the list of opportunities for embedded system design. So these are all the companies which they are providing various opportunities in embedded system platform. So as a mechatronics students, we have to update what are the robotic technologies and what are the embedded system companies and what are the opportunities they are providing and what kind of skills they are expecting from students' point of view. So these are all the companies they are providing in embedded system platform. Data LC, ITM Systems, Infosys, HCL Technologies, KBIT, Cummins, Emphasis, Symphony, Sonata, Mistral, and Texel, and Robosoft, and Robert Bosch. Something. These are all the familiar companies which are all around in the India. So we have to develop a lot of skills to be an embedded system engineers. So what are the skills we have to develop? Because every day we are studying all the branches according to the engineering, all the branches we are studying, but the lack of skills will be leads to the unemployment. So what are the skills to be needed to be an embedded system engineers? Learn the technologies that make internet possible. We have to update like artificial intelligence, machine learning, deep learning, and blockchain technologies and data sciences. So these interdisciplinary skills and technologies we have to update in various platforms like Udemy and Coursera. So likewise, we have to update the interdisciplinary skills also. So next, learn something new outside of your comfort zone. So already we are familiar lot of technologies and lot of subjects in your mechatronics environment. So something beyond that, something content beyond the syllabus, you have to update to be a successful technological platforms. The next one is third point, become experienced in the real-time operating system. So that's why they have explained in unit 2, we have to concentrate on real-time operating system like Windows CE, QNX, VxWorks. The next one is fourth point, know your software as well as thinker with the newest processes. So we have to update the newest processes, and we have to familiar like Arduino and Raspberry Pi and PIC microcontrollers. So we have to familiar in that particular programming platform and hardware platform also. The next one is get comfortable with open source software. So we have to design that particular project work will be based on your open source software, not that much complicated software platform. The next one is the last point. We have to connect that. We have to learn that the wireless connectivity. So wireless connectivity means we have to update the technology means IoT and IIoT and IoMT and IoBT. So these are all the technological platforms we have to update when we go for the skills development, right? So okay, so hereafter in engineering platform there will be a 70 to 900 courses are available in Anna City, but we have to update the artificial intelligence, machine learning, deep learning, data science, and blockchain technology. So these skills will be applicable in all the fields, even though in medical field also the artificial intelligence and machine learning are going to a tremendous role. So in this, likewise, we are going to concentrate in machine learning. Nowadays, that the machine learning will be updated to transform learning. So these are all the skills we have to update in embedded system design, right? Okay. So in unit 1, we are going to see about what are the embedded system, what is the classification, what are the examples, and what are the hardware software co-design, and what are the hardware software platform, and what is meant by processor technology, IC technology, and what is meant by design technology. So these are all the concepts we are going to see in unit 1, right? So in unit 1, the outcome, the need of embedded system and their development procedures, and involved in various design metrics and quality parameters. And we are going to study about the hardware software code design and what are the issues behind that hardware software code design. Okay, so what is meant by an embedded system? So first definition. So and what is before that if we are going to see about the embedded system before, what is meant by a system? A system is an arrangement where all its components work according to the specific design rules. So it is a method of organizing, working, or performing one or more tasks according to the fixed plan. So a system means normally it's a type of it's performing some task. If you are giving some input in the sense within that prescribed plan or rules, it will provide a particular output. That's a system. Then what is meant by this is difference between system and embedded system. An embedded system is a combination of hardware and software designed for a specific function. That is the main word. So that embedded system is a combination of hardware and software to do a particular task, right? So that's called an embedded system. Then okay, what are the real-time examples of embedded system? So car, washing machine, MP3 players, mobile phones, video games, digital cameras, DVD players, GPS, household appliances. So these are all the real-time examples of embedded system, because these are all the components which is forming by hardware and software. It's a combination of hardware and software to do a particular task. So car is mainly used for the driving, the washing machine to clean the clothes. So MP3 players to hear the songs, mobile phone for communication. So these are the specific applications. So that specific application, we can't transform from one device to another device. Like we have the car functioning, for the performance of functions of car, we can't implement in the washing machine. So that's why that main specific function will play a vital role, right? Okay, so that's why these devices are all called as embedded system. So these are all the examples of embedded system. So game machine, electronic book tablet, television, industry, broadcasting, medical, digital signature, amusement machines, printer, car, mobile phones, smartphones, cameras. So these are all the examples about embedded system. So these are all the systems which performing some specific task. If we consider some medical broadcasting system in the sense, it will receive the signals from the patients. The doctor is somewhere, so the doctor will came. We can it can able to the system signals which is coming, and they will display it in a broadcasting medical devices. So from that they are going to analyze the patient status, and then according to the patient status informations, they will provide some treatment procedures. So nowadays the IOMT, Internet of Medical Things, will play a vital role. So everything is an applications of that artificial intelligence and machine learning. So next one is the amusement machines and digital signatures. So we have already we have seen in some government transport. In the transport, they have displayed the source and destination through this LCD display. So that is also called an examples of embedded system. Right. Okay. Likewise, digital still camera, smartphones, mobile phones, car, printer. So these are all the examples of embedded system. Right. Okay. So what are the characteristics of embedded system? So there are three types of the three characteristics of embedded system: single function, tightly constrained, then real time performances. So these are the three main constraints when we go for the embedded system design. What is meant by single function? So an embedded system usually executes only one program repeatedly. So for example, a pager is always a pager. So in contrast, the desktop system executes variety of programs like a spreadsheet, word processors, and video cameras with the new programs added frequently. So likewise, I explained in the previous slide, we can implement one functions in that particular system only. We can't implement the functions in all the systems. So that's why they have explained in the pager. So pager is an application for that particular device only to send the information from source to destination. A desktop system is not an embedded system because it's having variety of applications, right? Okay, so a desktop system or laptop system, it's not considered as an embedded system. So every embedded system, it's a single function only. That is the main characteristics, right? Okay, the next one is tightly constrained. So all the computing system have constraints on design metrics, but those on embedded system can be specifically tight. A design metric is a measure of an implementation feature such as cost, size, performance, power. So an embedded system often must cost just a few dollars, must be sized to fit on the single chip, must perform fast. So real-time minimum power consumption. As usual, we are expecting the cheap cost and the performance should be high, and the cost will be low, the size will be compact. So these are all the expectation when we go for to buy one embedded system. So that's why the constraints are called tightly constraints, right? Okay. The next third one is reactive and real time. So many embedded system must continually react to change in the system environment and must compute certain rules and results in real time without delay, right? Okay. So every real time system must meet some deadline. So within that deadline, they have to complete that particular task without any delay. Likewise, for example, a car cruise controller continuously monitoring and reacts the speed and brake sensor. So a car, if it hurdles meet that particular car in the sense, it should uh, respond that particular brake system. If it not responds that brake system at that particular deadline, there will be a major disaster, right? Okay. So there are two types of real-time system: hard real-time system, soft real-time system. So in hard real-time system, likewise, if we see that already we have seen that Kerala crash, uh, that aircraft will reach that particular deadline or particular runway with that particular time. So without that, not achieving that particular deadline, it will be a major disaster. So an embedded system product, if it reach that particular deadline within that particular time limit, if it's not creating any disaster in the sense, that's called a soft real time. If a embedded system within that particular deadline, if it's not functioning, it will create a major disaster in the sense, that's called a hard real time. So for a hard real time system, always we are telling that the missile operations and the aircraft and satellite launchers. So in case of soft real time system, in the sense likewise DVD players, sometimes MP3 players. So these are all the examples about soft real-time systems and hard real-time systems, right? Okay, so in this slide, we are going to see about the basic functional block diagram about digital still camera. So a digital still camera is an embedded system. So in unit 1, they have explained the basic functionalities about a digital still camera. So digital still camera, first the image signal will be converted into that analog signals converted into digital signal. So already in this block diagram, we are having the charge coupled device preprocessor, pixel coprocessors, digital to analog converters, JPEG codec, microcontroller, multiplier, accumulator, DMA, direct memory access controller. The next one, display control, memory controller, ISA bus interface, URP, LCD. So in this, image signal will be converted into a digital signal to that particular CCD. So charge coupled devices, in this we have the CMOS sensor, which is converting that digital signal into that color signal. That means in this next slide, so this is a charge coupled device. In this IC, we will have in digital still camera. So what is the operations behind the charge coupled devices? When and light is coming through this image sensor, it will convert that it will convert that signal into electrical signal output. That is a basic principle behind that CCD, right? Okay. So next one, we are having the pixel coprocessor. So pixel coprocessors will control the JPEG codec, microcontroller, and multiplier and accumulator. So last, finally, the digital to analog converters will produce a digital output. The next one is the JPEG codec will control the compression and decompression operation of the particular image. The next one is all the signal, all the images will be stored in that particular DMA controller. What is meant by DMA controller? DMA controller means without that microcontroller operation, it will take all the responsibilities to control all the operations. So likewise, the memory controller will have all the image functionalities. The next one is instruction set architecture. Bus interface will control that interface to the digital still camera to the particular PC. The next one is UART. It will be communicate to easier to the digital still camera to the particular desktop computers. At last, the LCD display will display the particular images through that particular LCD display. Right? Okay. So these are all the working principles about digital still camera. Right? Okay. So the major 2 points is how a CCD is working. That is the first point. The next one is how the microcontroller is controlling all the process. That's okay. That's the two process will become the digital still camera. Right. Okay. So this is a latest Sony A74 digital still camera. So I have given that image URL. It specifies what are the specifications which is behind that latest still camera. So next one is the design metrics. So the design metrics means already if you are designing an embedded system, in the sense the 4 factors will be major role. The first one is power, the second one is size, the third one is non-recurring engineering cost. That means additional cost to modify the particular design. The next one is performance. So if you are the size will be increasing, in the sense the performance will be a major role. If a power will be increases, in the sense the size also increasing. So these four parameters will depend on each others. So when we go for one successful embedded system, in the sense these four parameters will be a major role to design all the embedded system product. Right? Okay. So up to this, we are completing the first unit, the design metrics and the digital still camera. Okay. So in this lecture, we have learned about what is meant by embedded system, what is the types of embedded system, and what are the characteristics of embedded system, and one digital still camera functioning and applications, and what is the design metric. Okay. So up to this, I have stopped here. So in the following slides, we are going to study about various embedded processor technology, IC technology, and design technology. Okay. Thank you.